Talk about writing inequalities and represent solutions. So let's go through our first problem. So in our first problem, in our do now, we're going to talk about just inequalities in general. So the school bake sale results are given in the table. If more than 20 of a baked good are sold, then more baked goods are made. Use inequality B is more than or greater than 20, where B represents the number of goods sold to determine which baked goods need to be made. So we are looking for baked goods that are more than or greater than 20. Cakes, no, that is not more than 20. Cookies are, that's 45. Cupcakes are, and pies are not. So cookies and cupcakes are more than or greater than 20. So, and before we continue, you've got to know the vocabulary words with the inequality signs. Which one are which? For example, if it's facing this way, it's less than or fewer than. So, for example, if you have this number, x is less than number 4. X is less than 4. Can you name some examples or numbers that are less than 4? 3, -6, 2, 1, 0, -7, 8, 9, -9, -10. Those are all. Can it include 4? No, 4 is not less than 4. It's equal to it, but not less than. What about this one? If it's facing this way, it's greater than or more than. Name some numbers that are more than 7. 8, 9, 10, 11, 12, 13, 14. Can I include 7? Because that will be equal to. Now, let's get a little harder one. These two where kids get a little confused because they're not used to these two. You're taught that these two, less than or more than in elementary school, but not so much in junior high. Not so much in 5th grade. So we have less than or equal to or at most. So x is less than, but equal to 6, or at most 6. So it can be 6. That's the most it can be. 6, 5, 4, 3, 2, 1, 0. It can include 6 because it said equal to. So at most it includes these numbers, 6, 5, 4. Those are where the maximum it could be. 6, 5, 4, 3, 2, 1, 0. And last but not least, greater than or equal to or at least 5. So name some numbers that are greater than or equal to 5. 6 is greater than 5. 5 is greater than or equal to 5. It's 5, 6, 7, 8, 9, 10, 11, 12. Because the least amount it could be is a 5. So look at the situation below. Circle the numbers. Circle the possible numbers that it could be. So it costs more than $6 to ride the Uber. Uber is like a car transportation service with private citizen. So it costs more than $6. Well, 10 is more than $6. 11, 12, 13, 14, 15. What about 9, 8, 7? Can I circle $6? Is $6 more than $6? No, it's equal to. So all of these. So how would I write this as inequality? X is more than $6. Are all these numbers more than $6? They are more than $6. Next one. There are less than 7 houses available for sale. So there's 6 houses available. 5, 4, 3, 2, 1, 0. So all these numbers are less than 7. So x is less than 7. So are these numbers? Is 6 less than 7? Yes. 5 less than 7. So that's why I like to check my work to make sure it makes sense. Now can you create an original statement that makes sense? There are at least 3 people at the game. At least. That means it must include at least 3. It must include 3. So least. 3 is the least it can be. So it has to be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. So what you can do is, so x is equal to 3. That's why I put a line there. But it can be more than 3, like 4. Well, is more than or greater than 3, or at least 3. Is 5 at least 3? Yes, it is. Least. So again, least and most. So if it's, I'll be honest, I get confused too. So this is how I memorize it. 5 is more than or greater than or equal to 5 or at least 5. So least 5 could be, it's the least amount, so everything has to be above it. If it had been this way, x is less than or equal to 4 or at most 4. 4 is the top it can be. 4 is the most it can be. So what are the numbers below it? 3, 2, 1, 0, negative 1, negative 2. So Mr. Williams decided to buy a suit and pair of shoes. He wants to spend less than $350. The price of the suit is 3 times the price of the shoe. Use the table to find 3 possible purchases Mr. Williams could buy. In addition, find at least one purchase that he would not buy. So we need to find where he can buy. So for example, if he spent $100 on shoes, the suit is 3 times that price. That would be $300. So he spent $400. Is that less than $350? No, it is not. Fine. If he spent $50 shoe 3 times, that'll be $150. That's $200. Is that less than $350? Yes. Let's do 70. Is 70 is cost of shoe 3 times it is $210, and then that will add up to $280. That is yes, less than $350. What about 80? 3 times it is $240. It adds up to $320. Yes. So can you write an inequality? So the cost of the shoes and suit have to be less than $350. Less than $350. So we could do it like this way. The shoes and suit are less than $350. But what if we want to use variables or symbol? So the shoes is X plus the suit is 3 times the shoe. How do you say 3 times shoe? So it's 3x, 350. So x plus 3x is less than 350. Then take it more into high school. In high school, your teacher will ask you to simplify this. What is x plus 3x? 4x is less than 350. I'm okay with this one or this one for junior high, the first two. But in high school, your teacher will ask you 4x, and then you will have to solve it so you can know every instant. In our next YouTube video, we will actually solve this, so we will know every time your shoe price have to be. So that means you can determine the suit. So it all has to be less than $350. If you want to know, I'm curious myself. 350 by 4, 7, 8, 32, 37, 28, 2. So it has to be your shoe has to be less than $87.50. If it's less than $87.50, then you 3 times that, and then you'll have where the shoe and suit will always be less than $350. And we're going to learn something called inverse in our next slide. What's the opposite or inverse of 4 times x? Divide by 4. You do the inverse of it because you want to isolate the x. But let's get back to our lesson. In our lesson, on the number line, the open dot means the number is not included in the graph. Do you see how these do not have less than or greater than? You use these inequality signs, less than or greater, more than, or less than. So if you draw this one, less than means you draw a line and an arrow to the left. More than means you draw a line and an arrow to the right. So let's look at the first one. Can you think of numbers that are less than 6? 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So you go to 6 and you draw an open circle. That means you are not including. That means you're starting at 6, but you're not including. And then, since all of these numbers are less than 6, you shade this in, and those numbers are less than 6. This is how I did. This is how I learned it in high school. I actually learned this in high school. And you're learning this in 6th grade. Do you see, this is a hint, so I know this is an open circle because it does not include 6. Do you see how this inequality sign, it's like almost like an arrow right here. It's pointing this way. So I point this way. It only works if your variable or symbol is to the left side. So for example, if it was this way, 6 is greater than, or 6 is greater than x, you would have to flip it around. So 6 is more than 6. Then it will work that way. So the next one, think of numbers that are larger or greater than negative 8. Well, negative 7, negative 6, negative 5, negative 4, all these numbers are more than. So we go to negative 8, open circle. Why open circle? Because you're not including negative 8, and you're going to include all of these numbers, because all these numbers are greater or more than negative 8. Again, super hint right here. Do you see how this is an arrow almost? This arrow says you need to point numbers here. So that's why I am shading all this. That's just a shortcut. But the other one is the mathematical reason. So you circle all the numbers that are more than negative 8, and that's why you're shading it to the right. But for hints this arrow is saying point that way. Next one. On the number line, the closed dot means the number is included in the graph. You use these inequality signs more than or greater than or equal to, or at least, that's the least it could be, and at most would be, wait, let me go back again to make sure I know it. At most, yeah, wait, at most, yes. So this one is at most. This one is at least. So at most, at least, at most, or another way to say is greater than or equal to, or this one's less than or equal to. So graph numbers that are less than but equal to 8. So we're including 8. So all these numbers are less than or equal to 8, and so on. So because we are including 8, you have to bubble it in. This is part of the problem. 8 is less than or equal to 8. And we shade this way because all these numbers will be less than or equal to 8. Again, do you see how this arrow is pointing this way? You see that arrow right there? That's how I do it. So at most, 8 is the most. That's the highest, the maximum it could be. And last, at least. -4 is the least where it stops at. So can you name numbers that are greater than or equal to -4? So -3, -2, -1, 0, all these numbers. But can I include -4? Yes, you can, because it's an equal to. So it's a closed dot. First of all, it's an open dot. But since we are including -4, we have to color it in, and then you shade it towards this way. You know what? Let's go back and practice some more. So last time we did this one. So x, all of these numbers are greater than or equal to 3. So I include, so an open dot, and then I close it up because I'm including 3. And I shade in all those because these, as you can tell, these are numbers I circle. The other way to do it is more of a shortcut, is you see this arrow says point that way. And next one, less than 7. So I open dot for 7. Am I including 7? No, I am not. That's why I should not color it. So it shades this way because all these numbers are less than 7. Also the arrows point this way. Next one, last one. I circle 6, open dot. Am I including 6? No, I'm not. As you see, all these numbers are shaded. So be shading that one. Also, shortcut, arrow pointing that way. So, last but not least, can you translate now, given the number line, can you translate back into inequality? So it's reverse. So as I can tell, it's a closed dot. It's a closed dot. And it starts with -5. And all of these numbers, so it's naming numbers that are greater than -5, but equal to. So these numbers are more than or greater than or equal to -5. Another way to do it as a shortcut, this is how I do it, really. I see it's -5, so I write -5. I see it's a closed dot, so I draw it like equal to. I put X here, and I see the arrow is pointing that way. So it's pointing that way, so I need to point this way. But mathematical why are we doing this? Is you're naming numbers that are greater than or equal to -5. Let's just plug it in. Is 4 greater than or equal to -5? It is. Is 5 greater than or equal to -5? It is. Let's try our next example. And this one is a closed dot, and it's 12. So it's naming numbers that are less than or equal to 12. So Arrow is pointing this way, so that's why my arrow is pointing that way. So let's check our work. Is 8 less than or equal to 12? It is. Is 0 less than or equal to 12? It is. Again, it is a closed dot. It's including 12. That's why I drew this equal to. All right, this is an open dot. Starting at 15. So it's saying name some numbers that are greater than 15. So name numbers that are greater than 15. So, so messy, so messy. X is more than 15. So name numbers that are more than 15. 16. We'll plug it in. Can 16 more than 15? Yes. 17? Yes. 19? Is 20 more than 15? It is. Another way, shortcut is, do you see how this is facing to the right? Is this facing to the right? It is. And next one, we are starting at 22 and a half. As you can tell, it is a closed dot, so I know it's going to be equal to. Name numbers that are greater or more than 22 and a half, but equal to 22 and a half. So numbers that are more than, so let's play it. Is 23 more than 22 and a half? It is. Is 26 more than 22 and a half? Yes. Is 30 more than 22 and a half? Yes. Again, as a shortcut, do you see how this arrow is pointing more to the right? Do you see it's pointing to the right? And last, I think we have one more of this. What whole number or integer is between 14 and 16? 15. And it is an open dot. I'm not including 15. So I need to find numbers that are less than 15. Less than 15. So let's try this one. X is less than 15. Is 10 less than 15? It is. Is 14 less than 15? It is. Again, the arrow is pointing this way. So that's why I drew the arrow towards that way. And last but not least, so it's 3.5, 3.5, whatever you want to use. If you want to be even more, 7 halves. All right, so name numbers that are more than, greater than 3.5, but do not include open dot. It's like do not include that. That's not part of it. So X is more than 3.5. Again, we could plug it in. Is 4 more than 3.5? It is. Is 5 more than 3.5? It is. So it all works for the constraints. But again, this is how I do it. I see this is facing towards the right. So if I had made an arrow, it would have faced the right. So what we learned in this one is we practice the vocabulary less than, greater than, less than or equal to, or greater than or equal to, at least, at most, and then at least. And then we learn how to graph stuff. So open dots means it's less than or equal to. Closed dot means less than or equal to, or greater than or equal to. It includes that numbers. So if you had to graph stuff, for example, it says you start with -4. You can actually, on the number line, you can actually circle them and do the mathematical reason why, which you should. Like, think of numbers that are greater than or equal to -4. And you circle it, so you know where to shade. As a shortcut is, this is an arrow. It's saying since the variable x is on the left side, you're fixing this way. And if you are given a graph, on the other hand, like this one, could you turn it into equality? So this includes 22 and a half. So, and all these numbers are more than or greater than 22 and a half. That is why it's this one.